This is the second video on section 7.5 cylindrical coordinates. In example 223, we're going to convert rectangular equations to cylindrical equations. In example 224, we're going to convert cylindrical equations to rectangular equations. So for part A, we have y equals x. I've drawn this in the xy plane. So in the xy plane, this is just the line y equals x. In 3 space, it's actually a plane, because in 3 space, z can be anything. But its intersection with the xy plane is just this line. And this will help us. And so we know that x is equal to y. So we have r sine theta equal to r cosine theta. Sine theta is equal to cosine of theta. So theta is equal to pi over 4. So theta is pi over 4. So again, in R2 it looks like a line, but in R3 it's a plane. So theta is constantly pi over 4. R can be anything, and z can be anything. Here we have x squared plus y squared is equal to 9. In R2, this is a circle centered at 0, 0 of radius 9, but in R3 it's the cylinder with that circle as its base. And so x squared plus y squared is r squared, and so r squared is equal to 9, so r is equal to 3. Now notice, when we're using cylindrical coordinates, the cylinder is very easy to describe. It's just r equal to 3. And theta can be anything, and z can be anything. So we didn't put bounds on z. And so describing a cylinder with cylindrical coordinates is a simpler equation than doing it with rectangular coordinates. And then finally, we have the x squared plus y squared is equal to z. Again, we substitute here. X squared plus y squared is r squared, so we just write that as z equal to r squared. For example 224, we'll go the other way, but what we did in example 223 will help us. So here we have theta is pi over 6. Let's think back to part A in the previous example. Theta is pi over 4. In R2 that gave us a line, in R3 it gives us a plane. Same thing here. In R2 it gives us a line, in R3 it gives us a plane. The question is what line and what plane? Well, remember, y divided by x is tangent of theta, so y divided by x is tangent of pi over 6. That means y is x times tangent of pi over 6. So y is 1 divided by square root of 3x. In R2 it's a line, in R3 this is a plane. For B, we have r is equal to 5. What about over here? R is equal to 3. In R2, that's a circle centered at 0, 0 of radius 3. In R3, it's a cylinder with that circle as its base. Same thing here. In R2, this is a circle centered at 0, 0 of radius 5. But in R3, it's a cylinder with that circle as its base. And again, a cylinder, r equal 5, is much easier to represent in cylindrical coordinates than in rectangular. And finally, for part C, it's actually just this part C going the other direction. So we have z is equal to r squared, z is equal to x squared plus y squared. And so it was similar to this part C.